So first I'll start with what is wrong with chips. I mean, I guess this is kind of obvious to this crowd already, but I mean, it's the long development cycles. It takes many, many months, I mean, years to get a complex chip to tape out, and it's very expensive. I think this is one of the key issues for companies like us who buy lots of chips, and because this increases risk and reduces competition. So we will have only a small number of suppliers who can actually afford a chip in 7 nanometer or 5 nanometer. And reduces competition, reduces innovation, and this is a big problem. Also, when you are actually building the chip, there's a lot of repetitive work. So for almost everything we are looking at, we need PCI Express, DDR, or HBM. And just to get these IPs in and test them and put them in a chip, it requires a lot of effort. So this is replicated effort across many teams in the industry. And I think this, just by eliminating this effort, will reduce the cost and increase time to market tremendously for these chips that we are looking at. And also, I mean the standard issues like analog mixed signal, you have to move them to the next node every time you change a process node, and reduced yield. And I think this is another big issue that, so as you get more and more complex chips, then you put a lot of pressure on your SoC teams to actually integrate all these IPs and make sure it works. And you need lots of people to work on these, and it also, again, reduces the number of companies who can actually afford this. So, I mean, the current state of chiplets is, as Bob said, there are chiplets in the market, but these are mostly single company doing it for their own use cases to improve yield, reduce costs, and get more efficient. But as far as I know, there is not much of a collaboration in the chiplet area currently. So what can be a potential feature for chiplets? So this image here is like, I guess, a dream for anybody who wants to put chips into operation. So in traditional workflow, you start with soft IP and then do SoC integration, do backend tape out, and you get a chip. So hopefully chiplets will reduce the time to market tremendously here by you will have the chiplets already that are fully tested and working. The only thing you have to do is integrate them together and test it, and you have a chip. So I guess to get there, we need to have a really simple and open interface. Think of it like AXI for IPs. So it's very easy for any company to build IP right now and to sell it to anybody who's building chips, because all you have to do is just put an HP interface and an AXI interface, and that's it. And I think it has to be as simple as that for chiplets too. And we need to have, of course, a marketplace for chiplets where we have the common functionality available. So what are these? So DDRs and PCI. So I think that's, especially coming from a data center point of view, I mean, these are like the main IPs that all the chips we might put into data center will have. And network interfaces, there might be some large SRAM-based caches for some applications that might be useful. So eFPGAs for some use cases, and of course processors, the main processor on the chip. So these are all common things for any kind of domain-specific accelerator you do. You will probably have all of them, or at least a subset of these chiplets. So I mean, I guess I want to say that, I mean, don't just look at SmartNICs, think of also compute-intensive, bigger, more complicated chips too. I'm not saying SmartNICs are not complicated, but I mean, just don't think of it only for chiplets, only for SmartNIC solutions. I mean, think of it as accelerators for, I mean, like if you see this box, I mean, you can, hypothetically, this is all domain-specific accelerators might look like in a data center. So you have DDR, you have PCI, you might have eFPGA, you might have an SRAM. And in the middle, basically, if you have this vehicle all set up, the only thing you need to do is for every new application you have, you just change the chiplet in the middle. You can put an image processor, you can put an AI chip, you can put an encryption chip, you can put a compression chiplet there. And this will tremendously reduce the time for us to be able to put any new functionality into data center. I mean, I guess, I mean, like, rather than 18 to 36 months, if you have something like this, then a promising chiplet can actually see deployment in maybe 6 to 12 months. And I mean, I think this is really important. More companies can benefit from this, and also more companies can contribute to this environment if we have a chiplet-based development flow. And so how can we make this work? I guess, I mean, as I said, I think we need an open spec that is simple enough to implement, and it covers a wide range of applications. So it can cover low and high bandwidth situations efficiently. And the barrier to entry should be also low. I mean, common building blocks like maybe like protocol converters, FIFOs, arbiters, and some SerDes elements. I mean, they should be really cheap or free, so that, I mean, anybody can actually pick those up, put those in, and build a chiplet that works with the standard that we will come up with. And also we need, of course, tools. So now we need some discovery tools that you can use to discover chiplets that are in the market and easily see which chiplets can work with each other based on their sizes. How can you fit them in? And some automation there will be actually, I guess that will definitely happen once this takes off. And of course we need a big community so that we will have different types of chiplets that we can choose from. And yeah, that's all. It was pretty quick, I guess.